All right, we are on day 4 of our Algebra B review, and today we're going to be looking at factoring special products. Now this one is really important for you to notice the pattern, okay? It seems really easy, but it kind of pops up in different places. And so it's important that we review how to multiply this piece, okay? So we're just going to FOIL, so we're just going to do first, outer, inner, last. So if we start, first would be our x squared, outer would be our negative 2x, inner would be our positive 2x, and last would be a negative 4. And then if you notice, our middle two terms are opposites, and so they are going to drop. And then that would be our final answer. And so in today's lesson, you're going to be going backwards. They're going to give you this, and then you're going to reproduce the two binomials, okay? What I want you to notice is that both of these are perfect squares. Even though this doesn't look like a perfect square, there's a 1 there. So it's sort of like 1x squared is really 1x times 1x. Remember, to be perfect, it just means that you're multiplying by yourself. So it still can be a variable. And then 4 is perfect, which is 2 and 2. And then whenever the last sign is a subtraction, which I know this in a way looks like the middle sign because there's only one, but technically this is the last because it's really x squared, say, plus 0x minus 4. So whenever this last sign is a subtraction, then yours will alternate, okay? So what you're going to see in today's lesson is what they call the difference of two squares. Now, it's not super important that you know the title, but it is something that you might hear your Geometry B teacher or your Algebra 2 teacher referring to. So I just want to point that out to you. But if you look at the 6 questions here, what you're going to notice is that every single one of them is perfect numbers. Every single problem here has a perfect number in it. This only works if you have perfect numbers. So if we had x squared minus 5, this would not work. So that's why today's is called special products, because every single one of them today is going to be a perfect square. So if we look at number 1, it goes really fast. You know you're going to have your signs alternate 1 plus 1 minus. And then basically, again, s squared would be s times s. And then if you just take the square root of 49, you get 7 times 7, and you're done. Now, if you do want to check your outer, you get a minus 7, and your inner would be a plus 7, and so notice there's your 0. So really, there's not much for me to show you and teach you, so why don't you go ahead and pause the video here, and why don't you try these 5? All right, we've got t plus 9 and t minus 9. Now remember, it doesn't matter which symbol comes first, the plus or the minus. You just need one of each. Now number 3 is kind of backwards, but that's okay. We can still do 4 plus x and 4 minus x. Now please don't switch this. Don't switch this so it looks like this, because that's different. That's x plus 4 and x minus 4. And if you notice, that means the x squared is positive. And then when you do the last, that means the 16 is negative. And you have it as the opposite. The 16 is positive, not negative. So keep it the way it is. Don't switch it, okay? All right, number 4, you should have done 2g plus 5 and 2g minus 5. And again, the outers and the inners might seem strange, but if we work this out, that would be a negative 10, and this would be a positive 10. So they still do cancel. All right, and then we've got 6h plus, what is that, 11? I had to think about it for a second. 6h minus 11. And again, the outers and the inners will drop. And then number 6, we have 9 minus 7k, and then we have 9 plus 7k. And notice on that one, I did the subtraction first. No rhyme or reason to that, just sometimes whatever pops in my head first is what I go with, okay? All right, then the other special one looks like where we have the exponent outside of the parentheses. So if you remember this one, you're going to do x plus 4 and x plus 4. You're not allowed to distribute that square, because if you distribute it, you're going to miss the middle term. So what ends up happening here is if we do our first, if we do our outer, our inner, and then our last. So see how our middle two terms come together. So that's x squared plus 8x plus 16. If you remember when we did this, we did have a little shortcut. And our shortcut was if you multiply these together, so if you do 4 times x, you can just double that. Whoops, sorry, I don't want to square it. I want to times it by 2. If you double it, you get the middle term. Let's see if that holds true with a subtraction. So we have x minus 5 and x minus 5. And then let's FOIL it out. So we do first, outer, inner, and then last. Notice if we would have just multiplied these together, that would have been a negative 5x. And then if we double it, we would get a negative 10x plus 25. Now, before we move on, there's a couple other little things I want you to notice. Do you notice that whatever symbol is in the parentheses here, so do you see how this is a plus? Do you see how this last symbol is a plus and a plus? Notice this symbol was a subtraction. Do you see how you still have a plus at the end, but we have a subtraction here? So basically what I'm telling you is the last symbol, I'm just going to make a couple notes here. The last symbol is always a plus, but it's the middle symbol that kind of matches the second. So let's say the middle of the binomial, so this middle symbol matches the first in trinomial. So whatever this symbol is, it matches with the one in parentheses. And so I'll kind of show you down below here. So when I'm looking at this, remember, we're factoring. So whenever you hear the word factor, basically that means create the parentheses. I mean, that's kind of the layman's term of it. So if you hear factor, you need to get the parentheses. Now be careful, the 7 is the problem number. So kind of make sure you ignore that 7. So we have x and x. Notice our last symbol's a plus, which means they're both going to be addition signs. And then you just need to take the square root of 64. So if you take the square root of 64, you get 8 and 8. And if you check your outer, that's an 8, and your inner, that's an 8. 8 plus 8 is 16. Now, I don't really care if you leave it like that, but they want you to try to get into the habit of writing it as a square because it's been repeated. Like it's the same thing, you know, twice. So let's try number 8. Let's see if we can do it with the square. So we know it's y. We know that this, basically, it's always going to be a plus at the end, like we wrote up here. But when we look back, notice they're both pluses. And then if we take the square root of 9, we get 3. Now you might just want to, again, kind of ask yourself, if I was to multiply this together and double it, do I get a 6 back? And the answer is yes. Just like right here. If I multiply this together and double it, do I get a 16 back? And so you know you've done it right. So let's try number 9. Now the one thing we got to watch in number 9 is look at that symbol right there. So do you see that symbol is a subtraction? But that's okay. We just put a subtraction and then the square root of 25 is 5. And then you know you're done. Okay? So why don't you try the 3 on the next page? Just try 10, 11, and 12. All right, hopefully you quickly tried these. And if we work this out, we're going to go a, now remember there's a subtraction, so minus and then the square root of 81. And I still always like to check. If I multiply these together, that's negative 9a. And then if I was to times it by 2, not square, times it by 2, do I get this number back? And I do. So I know I've done it right. I just always like to check that. All right. Now this one, if you noticed, had a coefficient in the front, but that's okay. It's perfect. So we take the square root of 36, our symbol's a plus, and we take the square root of 49. Now, you might want to quick try, what is 6 times 7? So 6c times 7 would be 42. And if I were to double that, do I get my middle term back? And I did. So I know I've done it right. Sometimes it's good to do a quick little check because otherwise, they could try to throw a little twist at you. All right, try number 12, or check your number 12 here. The square root of 100 is 10. My symbol's a subtraction, and then square root of 1 is 1. I know that looks weird, but it is just 1. If I multiply those together, so if I do 10x times negative 1, that's a negative 10x. And if I double that, do I get my middle term back? And the answer is yes. So those are the two concepts. Now, really what you got to be careful of is when they mix them together. So in this section, it's mixed, okay? But why don't you pause it here and try it? Just remember, if it has two terms, then it's from the front of your paper, okay? If it has three terms, it's this style. So go ahead and pause it and give these a try. All right, number 13. Remember, there's no middle term, so they drop. So it's going to look like this, where you have one plus and one minus. So anytime you have two terms like this, where they're both perfect, it looks this style. So see how this has 3? That's not going to work. But do you see how this one has 2? So this is going to be 3x plus 10 and 3x minus 10. Now again, this only works if it's a binomial and both of these are perfect. They have to be perfect. And you actually have to have a subtraction. If this would have been a plus, so if we would have had 9x squared plus 100, I actually would be done. I wouldn't be able to do anything because this would be 3x. The only way to get a plus is to have both of your symbols the same. So if you have both subtractions, that's going to give you a middle term. That's going to give you a middle term. If you have both pluses, that's going to give you a positive and a positive. That's still a middle term. The only way you can get the middle term is if they alternate. Because what happens then is you have one of them is a negative 30, one is a positive 30, and so that becomes a 0. The only problem is a positive times a negative is a negative. So if you have a plus symbol in the middle, you would not have been able to solve this. You would have just been stuck. Okay, let's try number 14. So this is the one that looks like that because it's a trinomial. So it's p plus, and then if you don't know the square root of 196, you just have to take it. So the square root of 196 is 14. So they're giving you perfect squares. Now again, just quick check. This would be 14p, and if I double it, do I get 28? And I did, so I'm good. All right, 16, I get r, and then notice this is a subtraction, and then the square root of 169 is 13. Let me just quick multiply. That's negative 13r times 2, which is negative 26, so yep, I've done it right. All right, let's try 17. This is 2x, and then this is a minus, and then the square root of 9, and then I square it, and then let's just quick multiply. So that would be 2x times negative 3, which is negative 6x, and then if I double it, do you see how I get negative 12? So I've done it. So I know I've done it right. Now the reason why I'm having you guys multiply that out is because what happens if they would have done this to you? So let's just add one more on. Let's do x squared minus 10x plus 16. This right here looks just kind of very similar to 14 and maybe even a 16. But watch what happens. If I take x, notice this tells me it's a subtraction. If I take the square root of 16, I get 4. When I multiply these together, I get a negative 4x, and when I double it, I get a negative 8x. Is that the middle term? And the answer is no. So then this is incorrect. Well, so then you might be thinking, well, then what's the answer? Well, then you just actually have to factor it out because 16 has more combinations than just 4 times 4. It is a perfect number, but in this case, our middle does not work. So we could use 8 times 2 because 8 and 2 is still 16. And if we do our outer and if we do our inner, notice there's our 10. So you do have to be careful. Just because your first and your last are perfect does not always necessarily mean the shortcut is going to work. So please, please always try the outers and the inners to make sure you did it correctly. But that concludes our special factoring for day 4.